engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists.
Hello, and welcome to the show that brings you the latest in science, technology and medicine. I'm Sally LePage, and this week it's Q&A time. In this pre-recorded episode, we'll be answering questions from you, our listeners, such as: how close are we to developing a vaccine against the common cold? What's it like to live on Mars? And what are the weirdest animals in Antarctica? That's right, this week is dedicated to you. If there's something you've always wondered, get in touch and let us help you scratch that scientific itch.
The Naked Scientists podcast is powered by ukfast.co.uk.
Before we go any further, let's meet this week's panel. First off, a warm welcome to Antarctic marine biologist Hugh Griffiths from the British Antarctic Survey. Hugh has been on missions to both the North and South Poles to study the sorts of animals living in the coldest regions. Hugh, you must be pretty used to cold weather by now. So what are your top tips on staying warm as it gets closer towards winter?
layers. Basically, in my job, we get amazing clothing for surviving some of the most extreme conditions on the planet. But I still get cold living back here in Cambridge, where it's essentially in a swampland around the fens, and it's very damp, the air. So actually, be somewhere dry is also another good hint, because however well you dress, sometimes the weather and things can defeat you. So staying dry is a really important thing.
Just move. If you're cold, just move somewhere warmer. That's our top tip from our Antarctic scientist there. We're also joined by astrophysicist and cosmologist Sarafina Nance from UC Berkeley and Lawrence Berkeley National Lab, who researches the explosive death of stars, or supernovae. Sarafina, we hear the terms astronaut and cosmonaut, and you study cosmology rather than astronomy. What is the difference?
The biggest difference is that cosmology studies the nature of the universe, the origin, the evolution, and the fate of the universe, whereas astronomy studies the things within the universe that basically it's composed of, like planets and stars and, other cool exotic things.
So you're much more interested in the bigger picture?
Yeah, I like to think a lot about the bigger picture.
Excellent. Next up is infectious disease researcher John Tregonning from Imperial College London. John, you study infectious diseases of the lungs, and when your lab was closed because of the infectious lung disease COVID, you then wrote a book about infectious disease. I mean, talk about a busman's holiday. Can you ever escape infection?
No. We are, all of us, carrying so many different pathogens all the time, and bugs, up your nose, on your skin, all over your body. You have more cells of bacteria in your body than you have cells of you. So we are living in a microbial world.
And yet you still choose to spend your working hours studying them as well.
Right, you need to know about the stuff you live with.
Last but not least, our final guest is Nessa Carey, molecular biologist and Royal Society entrepreneur in residence at Oxford. Nessa, you love everything to do with DNA. There seems to be so many breakthroughs in genetics and DNA technology at the moment. Is it hard to keep up?
God, yes. That's why I'm really hoping the questions today are fairly straightforward, because otherwise I'm going to be sitting here going, I don't know, I've never heard about that. That's so complicated. So yeah, it's really hard to keep up.
Okay, so we've met the panel, but before we start asking them your questions, we like to kickstart the show with a little game of Guess Who. We've got a mystery sound, and throughout the show we will be dropping clues as to who or what our mystery thing might be. If you're listening in at home, see if you can guess it before the scientists can. So without further ado, here is your first clue. Well, who or what made that sound? John, do you have any ideas straight off the bat?
No, it sounds spacey, so I'm going to pass over to somebody who works in space.
Something spacey, interesting. Well, we'll give you hints as we go through the show, so keep thinking about that one. We're going to kick off our audience questions with you, Hugh. You study the biodiversity of life at the poles, particularly at the South Pole, the Antarctic. When I picture the Antarctic, all I can think of is endless white snow, super flat landscape, maybe a penguin or two. And it seems that our listener Jess has been thinking the same thing as me, as she asked, if Antarctica is so barren, what do the animals that live there eat?
Oh, that's a really good question, because Antarctica actually isn't as barren as it appears on the surface. So beneath that ice that you see, especially in the oceans, it's an incredibly rich and diverse place. But on land, the biggest plants are mosses and lichens and things, and the biggest animals are wingless midges. So the food chain on land is very short and largely microbial. But essentially, once you get into the oceans, you've got the biggest animals on Earth, the blue whales and everything, feeding on what is quite a short food chain for the mammals and birds and things. So you've got tiny microscopic phytoplankton, which is feeding these tiny animals that people have heard of that are called krill, which are a bit like shrimp, but they're actually a bit bigger than people think. So they're not microscopic. They're a few centimeters long and they can live a couple of years. And the krill poo is raining down on everything below, which is providing a huge amount of food source to the seafloor. And that, with the 24-hour daylight in the summer, means that there's a huge amount of food sinking down to the bottom of the sea. And the diversity there is tens of times higher than you get at the surface, where you end up with about 20,000 species. Lots of them are brand new to science, that are all eating what's raining down from above. And it's quite an amazing environment.
It sounds like life below the ice is a lot nicer than actually life above the ice, the bit that we picture when we think of the Antarctic. Is that right?
Oh, definitely. It's quite stable, but also there's this regular food supply. So you don't need to be all fighting over one bit of food. There's enough food for everybody. But also it looks a bit, in places, a bit like a coral reef. And there's a lot of colour and diversity and 2-metre tall sponges that live for thousands of years. You've got all sorts of amazing filter feeding animals and ones that eat the mud. And then at the surface, the places we think about, it's a really harsh place where everything's killing each other to stay alive, because they're in a place where it's boom and bust, summer and winter. And even the ducks on the subantarctic island of South Georgia eat flesh because there's no plant material for them to eat in the winter. So it's quite a harsh place to be if you're at the surface, but actually quite a nice place if you can cope with the cold water at the bottom of the sea.
I'm sorry, flesh-eating ducks.
Yes, the South Georgia pintail, the world's only flesh-eating duck.
That is a nightmare I never knew I had until now.
It is pretty horrible. It is almost, it's not a dog-eat-dog, but it's a duck-eat-duck world out there almost in South Georgia, because if you go to the beaches, there will be birds waiting for seals to be born so they can start attacking and eating them, or penguins coming ashore being eaten by seals as they come in. And it is like a 24/7 David Attenborough documentary of everything eating each other.
Will the deep Antarctic, will that be protected from global warming? Will we see that those ecosystems remain more intact, or will even that be affected?
So you're definitely right that the shallow waters around Antarctica are some of the fastest warming waters on Earth. And we're losing things like sea ice and things. So actually, indirectly, they'll be affected by things like the sea ice disappearing, because this food that rains down, very often a lot of the species are dependent on the sea ice over winter and things. So if that's missing, you'll have less krill or you'll have less phytoplankton. So there's less food, but also those deep waters are warming. And it's kind of like when Antarctica is warming in the middle of the continent, that you go from -50 to -48 or something. So it still feels very cold. And for us, that seems like it's not a big change. But actually, for some of these animals that are very specially adapted to cold water, the idea that something else could come in and compete with them, even with a small amount of warming, could be a bigger danger than the actual warming itself.
And we'll get more onto that later on in the show. From one bleak landscape to another, Sarafina, let's talk about living on Mars. We've had this question in from listener Alex. What do you think the most challenging aspect about living on Mars will be for humans? Sarafina, you're particularly well qualified to answer this question because you spent 2 weeks pretending to live on Mars, am I right?
That's right. I attended a Mars simulation, which was basically living on a volcano in Hawaii and living like I'm an astronaut on Mars with a crew of 4 other people and doing research and testing our limits.
How close did they get to simulating Mars? Did they go around spray painting all of the volcanic rocks red?
The landscape on Mauna Loa, which is where we were, is actually pretty similar to the landscape on Mars. That volcanic rock replicates very similar to what Mars is like. And then you're sort of plopped in this isolated, harsh environment where you live in a habitat.
By a habitat, is that like a bubble like we see in The Martian?
Yeah, so it's this white dome that is completely sealed off from the elements outside. And every time you leave the habitat, you need to be approved by mission control. You need to suit up in your EVA or extravehicular activity or spacewalk suit. And then you get to go do research. Then you return and reassess and then go do everything again the next day. So it really is modeling as much as possible what it might be like to be astronauts on another world. You know, we all lived and worked out in the same place, no showers, tiny bedrooms, compost toilets.
What would you say to Alex is the most challenging part about that whole experience?
I think one of the most challenging parts was the food. Freeze-dried food every day, every meal for 2 weeks, and then just imagine for long duration missions that can be up to a year. It's very challenging. We had quinoa and bell peppers, and I don't think I will ever eat bell peppers ever again after eating those every day.
Is this the same food that they eat on the International Space Station?
So there's a little bit more variety, I think, on the ISS. You know, they just ate chili peppers, you know, granted they grew them there, but I think they have a little bit more, I don't know, opportunities to change food up. But that's one of the main things that they were studying early on at this habitat was how do we give enough variety to astronauts who are, you know, gone for a long time and what they eat. So they went through meal replacements, they went through freeze-dried food, and it ended up that some sort of full kitchen with freeze-dried food was a good opportunity.
You're probably ready to go and work in Antarctica now, because there's a lot of that has very high similarities with our people who do 3 or 4 months in a tent, and they just whatever they can boil on a tiny stove, and it's all freeze-dried and things. And you cycle through maybe 5 or 6 types of meal, and that's it, unless you have a very good field assistant who can turn 2 pans into an oven to make some bread in the field or something, which is a miracle.
I know many actually astronomers who have gone to do field work in Antarctica, and there's a lot of correlation with that. That's actually something I'm really interested in because there are potentially meteorite samples in Antarctica that we can collect to study for supernova, which is what I focus on.
From baffling British weather,
the sideways spines of the vertebrae coming off here,
to looking at a cheetah from the inside out, games making their way to the clinic, and what to eat in your garden. The Naked Scientists in Short podcasts bring you a top-up of short, compelling science stories. Listen and download for free at nakedscientist.com/short or subscribe to Naked Specials wherever you get your podcasts.
Still to come, female vultures that don't need no man to breed, and why is the moon a different colour to the Earth? But right now, here's the next part of our Guess Who game. First, we heard the noise it makes. Take another listen. And now, your next clue. This is a sound you couldn't normally hear with your ears. Sarafina, got any ideas there?
I have 2 hunches. The first one is it wind on another planet?
Interesting. And your second hunch?
Is it the resonant frequencies of planets?
Interesting. Well, we shall see as we get some more clues. Oh, I'm teasing you now, aren't I? John, it's over to you next. We have had a question in from listener Rohan, who asks, there's now a malaria vaccine being rolled out. Do you think we could wipe out malaria like we did wipe out smallpox?
Yes, optimistically, I think we can. And not just with the vaccines. I think there'll be a number of different ways. But if you go back 400 years, malaria was much more widespread. So Shakespeare had the ague, which we probably think was malaria, and it was associated with swampy grounds. And as the places like East Anglia were drained properly, the mosquitoes that carried the malaria disappeared. So through a program of getting rid of that family of mosquitoes that carries malaria, and some vaccines and some drugs that stop transmission and better bed nets, you could get to a place where we are malaria free. And remarkably, in the last year, China became malaria free. And there are relatively few countries that now have malaria. So yes, I think we can achieve that, and not necessarily through vaccines, although.
That's amazing. Such good news. What about everyone's favourite infectious disease, the common cold? Are we ever going to wipe that out?
No. so some things just because it isn't one thing. A common cold is a whole collection of viruses, bacteria, funguses, anything that can kind of get into your nose and inflame it and cause you to make snot and mucus is a common cold. There are as many things under the sun that can cause those as you can imagine.
Where does coronavirus fit on that scale between smallpox and flu then, in terms of viruses stable enough that we could wipe them out?
So coronaviruses, there's lots of different coronaviruses, where the one that's just kind of caused the pandemic is SARS-CoV-2. So it's the second kind of very severe recorded coronavirus in the last 15 years. But there are other ones that are kind of common cold coronaviruses that if you went around and swabbed people, you'd find in these kind of endemic coronaviruses. In theory, they are more stable than influenza. So flu, when it makes copies of itself, describe it as leaky. So basically, when it makes copies of its own genetic material, it's like when you make a photocopy of a photocopy of a photocopy. Each time you add it, you put in more and more errors. And flu kind of changes quite quickly over time, while coronaviruses have something called a proofreading ability, which is like somebody checking the photocopies and putting the original one back on and making kind of clean copies each time. So in theory, coronaviruses don't change as quickly as flu viruses. We have seen them changing in the last 18 months, but that's probably because everyone has had it. And so it's had much more opportunities to change. So the more kind of rolls of the dice, the more changes you'll get.
Well, Nessa, I've got a question for you now. I have seen in the news about a condor that is a huge type of vulture that has had chicks without mating with a male. How can that happen genetically? Because as far as I know, birds are like us in that they need both a sperm and an egg cell to combine to create offspring.
Right, so Hugh, I take your flesh-eating duck and I raise you a parthenogenetic vulture. So parthenogenesis is the phrase we use for creating live young without mating. We've had hints before that this can happen in birds, but we've never seen it in species like condors and vultures, which are these huge, huge scavengers. The really weird thing about these condors that did it, these female condors, is they actually had access to males, to fertile males. Normally, we only see this thing in birds of producing eggs and young with no males under extreme conditions where there's no males around. But this time there were males. It's just for some reason the females decided not to bother with them.
So it wasn't that that the condors didn't have a man. They just didn't want a man.
They just didn't want a man. They just decided that this time the vulture sisters were doing it for themselves. And these two females, so it happens twice, they laid eggs and those hatched, and it was little male condors that came out. And it seems like what happened was when the female first started producing an egg, when you do that, you basically half the amount of your DNA, because essentially each offspring gets half from mum and half from dad. But it looks like what the female did was she halved her DNA and then thought, I'll not bother with dad, I'll just copy this so that I end up with the right amount of DNA. And then we'll have a new condor. And they did it. And absolutely nobody knows why.
And did you say that the chick was male?
Both chicks were male.
But surely this means that if they've got exactly the same genetic information as their mother, wouldn't they just be a clone?
No, because birds are different from humans. In humans, the male has an X chromosome and a Y chromosome, and it's the Y chromosome that creates being a male. Whereas women are XX. They have two identical, what we call sex chromosomes. Birds are the other way around. So in birds, the male has the two sex chromosomes that are exactly the same. And the female has what's called a Z and a W. And so in these particular cases, the females passed on two of the Z chromosomes and created new males. Isn't it weird? There you go, flesh-eating ducks, take that.
That is incredible, John.
Could the dinosaurs have done the same if they're in a similar, family?
Well, yeah, that's a great question.
Isn't that what happened in Jurassic Park?
Which is, as we all know, highly scientifically accurate. It's not, spoiler, it's not. Birds are dinosaurs, basically. The dinosaurs didn't die out. They just changed into birds. So chances are maybe the dinosaurs did. We certainly know lizards do. You know those Komodo dragons, those really big, terrifying lizards that bite you when you die from blood poisoning, if you don't die from having your leg bitten off. Well, we certainly know that they can do the same thing. There's been females in zoos who couldn't get near a male and who have had created offspring. So yeah, it's basically, if you put enough pressure on almost any animal, apart from mammals, they manage to do this, but mammals can't.
Why don't we all just do parthenogenesis? It sounds great.
It certainly solves that problem of, can you find a decent boyfriend? If that's something you're struggling with, if you can't find the proper baby daddy. Mammals can't, because mammals have placentas, and we have systems built in that mean that you have to have some of your DNA from a male and some of your DNA from a female. If you don't, the offspring can't develop properly. So you never, ever get live offspring. It has been done once in mice, but that's because the scientists mucked about with the DNA.
That ruddy placenta getting in the way of...
I know, more trouble than it's worth.
Well, back to you now, Hugh, because right now everyone is talking about climate change more than ever, because as we are recording this, it's the middle of COP26, the climate change conference. You literally work on the melting ice caps that we always hear about. Have you noticed the effects of global warming on your research?
Any research in the polar regions has got that as a background, whether you're specifically researching climate change or not. So even stuff that I do at the bottom of the sea with a few creatures that either have loads of legs or loads of eyes or no eyes, always in the background is, how will these things be affected by climate change? Because we can see it out of the windows of our research stations, for example. We can see the glaciers retreating. I've been going to Antarctica for nearly 20 years now, and I can go places and see what's changed in my career, not my lifetime even, just my career. So it is scary that we can observe these things firsthand now, and it's not just computer simulations or models of the future. And we see it with the length of season of things that can live down there for us, or we have ecosystems that reach what we call tipping points, where something switches from one way of doing things to another in a usually irreversible way. So a really simple version of this is where the sea ice in the shallow water acts as a way of blocking some of the light out from getting to the bottom of the sea. So instead of a normal, like the beach in the UK where it's covered in seaweed, if you go just below that level in Antarctica, there would be animals dominating, covering the rock, like sponges and corals and soft corals and things like that. But if the sea ice starts to get thinner earlier, or even melts away earlier, you get more days of daylight at the bottom of the sea. And there's enough days then for the kelp and things to start to grow. And they start to grow over the top of these animals. And all it needs is a few extra days where the ice has melted a bit earlier, and you get this switch to a completely different system.
It reminds me a bit of coral reefs, in that once coral reefs have been bleached enough, all the slimy algae grows on the top, and then you'll never get your reef back. Once it's gone, and it's really hard to get it back, even if you return to the conditions it was at before.
Exactly. And it's that we could lose some of our specialists, especially with warming, that extra bit of stress. Some of these animals actually actively are fighting to keep their bodies held together in the cold. So less energy goes into reproduction or growth and things like that, because you're just holding your body together in the cold water. If the water warms up a bit, some of the things you're doing could actually be harmful to you, but also the competitors that don't need to worry about doing that extra effort, so they can eat faster, reproduce faster, grow faster, could all come in and outcompete you. And those other animals are quite far away, but it's amazing that we thought Antarctica was so isolated. But we have tourist ships going down there now, scientific vessels, we have fishing boats going down there, all of which can carry animals backwards and forwards. But we even have things like microplastics and things washing into Antarctica. So even a place that we thought was quite safe from our impacts has got things coming in. And we have something like 700 million pieces of kelp floating around the Southern Ocean at any one point. And all you need is one particularly bad invasive species to be sat on one of those pieces of kelp and get washed onto the right beach in Antarctica in a warm year, and it could become established. And that's why monitoring Antarctica and seeing where the most likely to be affected places are through climate change, ocean acidification, and all these other things is the job that we do.
Well, if you thought that a whole continent potentially being ecologically destroyed was bad enough, our next question is for Sarafina, and it's from listener Jamie, who asks, I've heard some reports that Betelgeuse might be about to turn into a supernova. Should we be worried about Betelgeuse exploding? What is the damaging radius of a supernova? So, Serafina, I first have to clear up. Is it Betelgeuse or Betelgeuse?
Betelgeuse. You were right on the money the first time.
Good. And as far as I know, it's in Orion. That's pretty much all I know about it. Tell us more about it.
Yeah, so it's the left shoulder of Orion. It shines bright red. So if you ever look up at the night sky and see the Orion constellation, you'll be able to spot Betelgeuse pretty easily because it's so red compared to the other sort of white stars. And it's red because it's a red supergiant, meaning it's very, very, very big. And it's later on in its stellar evolution life cycle than our sun, for example. So it has ballooned out and taken up this red color. And everybody, astronomers and non-astronomers alike, have been really interested in Betelgeuse, especially recently, because it has been fading and dimming. And people have wondered whether that dimming means that it might be close to exploding. So it's actually interesting because there's no real astronomical physical reason why it should dim before it explodes. In reality, we would think that it would actually get brighter before it explodes. And that's what we've seen, when we sort of look to other stars that have exploded. But that said, Betelgeuse is extremely close to us. It's about 600 light years away. And so we get a different perspective of the precursors or the progenitors of supernova by watching and monitoring Betelgeuse than we see from other stars. And so that has sort of tested our theories of stellar evolution to make us wonder if we understand exactly what goes on in a star before it explodes.
You say 600 light years isn't very far away. Does that mean I should be worrying, packing an emergency bag, something like that, in case it goes off?
So the good news is, well, there's two pieces of good news. The first is that it's probably not going to explode for another 100,000 years. So even though it's going through this sort of dimming and rebrightening life cycle, it turns out that that's actually because the surface of Betelgeuse is sort of expelling bits of dust. And that dust is obfuscating the star from our line of sight. And Betelgeuse simply appears dimmer than it actually is. So I like to say that Betelgeuse has been burping a lot, and we are sort of not seeing it because we're seeing the burp and not the star itself. So that's the first piece of good news. The second piece of good news is that it's far enough away that we will not really be impacted by the explosion. If we're still around in 100,000 years, we will simply see a very bright star that'll be as bright as the moon during the day and the night for about a month. And then it will sort of, dim away. And that's about as much of an impact as that explosion will have on Earth.
John.
How close is bad?
So, I mean, you have to, for example, obviously if our sun were massive enough to explode as a supernova, it's not. That's not how it's going to die. But if it were, we would be screwed.
So we're safe from the sun. Sun won't go supernova.
We're safe from the sun. However, it will expand into being a red giant. And sort of how Betelgeuse is a red supergiant, the sun will continue to expand in a similar fashion. And it will actually sort of envelop the Earth throughout its expansion. So, that's not good news for us.
At least we might have wiped out all infectious diseases by that point, John, though, if it's
yeah. That's the bright side.
And it'll take out the ducks too.
Yeah.
Much has changed for business owners, managers, and staff recently. But with over 30 years' experience in telecommunications, award-winning independent company Spitfire have the expertise to make sure you stay ahead and can keep on innovating. Whether it's connectivity, MPLS networks, firewalls, or phone systems, Spitfire can help. To find out more, go to spitfire.co.uk. That's spitfire.co.uk. Spitfire, telecoms and IP engineering solutions for business since 1988.
I'm joined by a panel of experts ready to take on your science questions. We've got supernova scientist Serafina Nance, marine mastermind Hugh Griffiths, viral virtuoso John Tregonning, and genetic genius Nessa Carey. Now let's return to our Guess Who competition. First, we heard a noise. Let's have a reminder. It's an odd one this week. We already know that this isn't a noise that you can normally hear with your ears. Your next clue is, I used to only exist in the tropics, but now I can be found all over the world. Nessa, who or what do you think it is?
Oh, okay. I'm going to go with it. Some sort of animal that transmits noise at an ultrasonic or a hypersonic frequency that we normally couldn't hear because our ears can't pick up stuff that low or that high.
That is a very reasoned answer, and later on in the programme we'll see if it is right or not. We are now halfway through the programme, and that means it is time for our quiz. We like to test our guests to make sure we have the finest brains science has to offer, and of course you at home can join in too and see if you can beat the boffins. We're going to pair you off into teams for this, so Sarafina and John, you are in team 1, and Nessa and Hugh, you are in team 2. You can, of course, confer. In fact, we strongly encourage it. And as we are recording this episode in the middle of the international meeting about climate change that is COP26, all of the questions this week are about being green. Right, well, round 1 is being green for our planet. Question 1, this is coming to you, Sarafina and John. If the whole world adopted a vegan diet, by what percentage would we reduce global agricultural land use? Is it A, 55%, B, 65%, or C, 75%?
John, what do you think?
I don't know.
maybe B.
Just go middle.
Like
classic
solid
multiple
middle ground.
choice.
Exactly.
For no other reason than it is the middle answer, you're going for B. The answer is C, 75%. Research suggests that if everyone adopted a vegan diet, we would also cut agricultural land use from 4 billion to 1 billion hectares. Isn't that incredible? Question 2, your first question, Nessa and Hugh. In the 1830s, the average person in the UK would have got by on just 18 litres of water per day. However, nowadays we are using over 135 litres a day. Toilet flushing accounts for a large proportion of our water use. What fraction of water used in the average UK home today goes down the toilet? Is it A, a fifth, B, a third, or C, a half?
Hugh, should we use their strategy and go for the middle one again?
I was going to
It
say
feels about right.
B sounded better than the other ones to me. B.
Go for B again, mostly just because it is the middle one. And this time, it is correct. The answer is a third of our water goes down the toilet.
One of the more disgusting things I learned while writing the book was that only 30% of men wash their hands after going to the toilet in petrol stations. So that crept up to 40% during the pandemic, but I think it's crept back down again.
Okay, so I'm now back on side with Sally and the can we follow the condors because the men are not doing well here. Yeah, you grubby creatures.
What does anyone touch inside a petrol station and how can I avoid touching it at all costs? Oh my goodness. Oh, I suppose they're using less water in doing so.
We're saving the planet through cleaner peeing.
Yeah.
Well, at the end of round 1, that's so far no points to Sarafina and John and 1 point to Nessa and Hugh. But you can still catch up. Round 2 in being green. Green is not only the colour of envy. Question 1 to Sarafina and John. Emerald, aquamarine and morganite are all types of beryl. Their individual characteristic colours are determined by metal impurities. What metal impurity gives emerald its green colour? Is it A, chromium? Is it B, copper? Or is it C, cadmium?
I think it's not copper.
Oh, okay.
What makes you think that?
I have absolutely no idea. I just feel like you would be able to see that. I don't know.
What was the first one?
We have chromium, copper, and cadmium.
Let's go chromium. It feels like that one, that sort of crystal color you used to do for precipitation.
We're going for
That
chromium.
feels right.
The answer is indeed chromium.
Woohoo!
Yeah.
Emerald is a green beryl coloured by about 2% chromium and sometimes vanadium. Aquamarine, which is obviously aquamarine coloured blue, has iron impurities, and the colour of morganite, which is a rose pink colour, can be attributed to manganese ions. Good job. So question 2 for Nessa and Hugh. For hundreds of years, copper ores such as malachite were used as green pigments. In 1775, Carl Wilhelm Scheele invented a new green pigment that took the world by storm. But what questionable component did he mix with copper to obtain this green colour? Was it A, potassium cyanide? Was it B, arsenic trioxide? Or was it C, mercury fulminate?
The arsenic thing rings a bell, but lots of painters did horrible things by licking their brushes and things and getting all sorts of things. So it could be any of those that would give you a nasty end. But
yeah, the radium women who painted radium paint onto watch faces used to have terrible poisoning after licking their brushes.
but lovely smiles.
Until their jaws dropped off.
Yeah.
Yeah. Well, I don't know. For some reason, I'm associating arsenic with white, but for no reason whatsoever.
Gonna have to press you for an answer.
Go on, Hugh. Go with yours.
Yeah, let's go with arsenic.
Go with arsenic. And it's a good choice. The answer is indeed B, arsenic trioxide. Napoleon is famously believed to have been poisoned by his wallpaper that had been painted with Scheele's green. Arsenic is found in surviving samples of his hair, but even if there wasn't enough in the paint to kill Napoleon, there was enough in his hair to cause illness. So, at the end of round 2, that's 1 point to Sarafina and John, and 2 points to Nessa and Hugh. So it's still all to play for. Round 3 in our Being Green quiz is It Ain't Easy Being Green. Kermit the Frog performed the hit song Being Green in 1970 for Sesame Street. As Kermit is a frog, this round is about frogs.
That is not at all tenuous. That's what I really, really like.
This is just because I really like frogs, so I wanted to do a round on frogs. So, with this Being Green round on frogs, question 1 to Sarafina and John. 40% of amphibian species are under threat, and a lot of that is because of a deadly frog fungus. This initially spread really quickly as frogs were being shipped around the world. What were they being used for? Was it A, as a mosquito control agent? Was it B, testing the safety of drinking water? Or was it C, pregnancy tests? Hugh, I see you know it, but this is not for you, so try and keep a poker face.
Can we call a friend?
Annoyingly, 3 stories down is the guy who works on frog funguses and would have the answer. So if you gave me 30 minutes to run down to Matt's office, I would have the answer.
Has he ever mentioned to you at lunchtime why frogs were such useful animals?
It's not pregnancy tests. What were the other 2?
We've got as a mosquito control agent, testing the safety of drinking water, and pregnancy tests.
I think it's B or C. Simply according to Hugh's reaction, I think it's B or C.
I'm going to go B.
We're going to go for B, testing the safety of drinking water. Hugh, put them out of their misery. What is it?
Pregnancy testing.
It is indeed pregnancy tests. Female xenopus frogs were widely used as pregnancy tests in the 1950s and 60s. And get this, a woman's wee was injected under the skin of a female frog. If she was pregnant, the frog would lay eggs about 5 hours later.
You're kidding.
I am not kidding. They shipped these
so
xenopus
cool,
frogs
isn't it?
all around the world for women to wee on them. And because they were shipping the frogs, they accidentally shipped the fungus with it. And now chytrid fungus is all around the world.
And the worst thing about this being radio is you didn't see the reactions of the other panelists when
That
they
is
found
true.
out that. That was just brilliant.
Sarafina is still yet to pick her jaw up off the floor.
Would you buy them in the pharmacist in with 2 lines on them?
I think you just go to the GP and say, "Excuse me, have you got a frog I can wee on?" There you go. Right, okay. Question 2 for Nessa and Hugh. Frog tongues are marvels of evolution. They are 10 times softer than human tongues and can catch prey in the fifth of the time it takes to blink. They are also incredibly strong. Researchers found out how much a horned frog tongue could lift relative to its body weight. If our tongues were that strong, what would we be able to pick up? Is it A, a small dog? Is it B, a medium fridge? Or is it C, a large car? And I'll just pause to let you imagine picking up each of those items with your tongue.
I can't talk anymore. I can't talk now. My tongue has now been paralysed by the thought.
I don't want to go for B again because we've gone for B on everything so far. So my brain is saying fridge, but my quiz head is saying they wouldn't give us 3 Bs in a row. So why don't we go for car instead? Because a dog, even my tongue could pick up a small dog now. So I'm not worried about that.
Have you tried?
Every day.
Chihuahuas, watch out if you're ever near the British Antarctic Survey Station.
Oh, let's go for the car because
I
really
want it to be car. I really do.
want it to be car. So do I.
You really want it to be the car?
Yeah, we really want it to be the car.
Sadly, wanting it is not enough. It is B, a medium fridge.
Oh.
You are right with your science head, Hugh. Horned frogs can lift 1.4 times their own body weight, and they can fire their tongue out at 4 meters per second. Isn't that astonishing? At the end of the quiz, Sarafina and John have 1 point, but Nessa and Hugh have 2 points, making Nessa and Hugh the winners.
Yay!
You get ultimate bragging rights among all of your friends. We're going to go back to the audience questions. John, we're coming to you next. As someone who studies lung infections, this question from LaJoy should be right up your street. Why do the most common infections attack our lungs and our ability to breathe rather than any other organ?
So you need to think a bit more broadly. It's anything that's inside you that faces the outside can get infected. So we get gastric infections, we get GU infections, so infecting how you pee, but also how you breathe. And that's because those areas, they have to be a barrier, but they actually have to exchange things as well. So our lungs are essentially, if you imagine a sieve, they're very, very fine mesh that allows the air to go in and the carbon dioxide to come out. But at the same time, that's going to give space for bacteria and viruses to come through them. So that's the reason, is that they are not just barriers, but they're exchange places. And that's why you don't get infection, say, on your skin, unless you get a cut. And then the bugs that live on your skin can get inside. If everyone now takes a big breath in, you've just breathed in 10,000 bacteria.
Oh, great. Thanks, John.
and probably 3 funguses and a whole load of viruses. And you're doing that all the time. And yet you're not sick all the time. We have all these mechanisms that clear your lungs out. The sort of snot and the bogey that you have that sucks everything up and clears it out. And unfortunately, people who can't do that as well, so people who have cystic fibrosis, have very sticky mucus in their lungs. And the bacteria get stuck in the lungs and can grow and kind of forms these colonies, very similar to like what Hugh might study in the bottom of the ocean. Actually, there is complex ecosystems in your lungs and of the bacteria that live there. And related to that slightly, but differently, is that on each tooth, you have a completely different tooth microbiome. So every single tooth has a unique fingerprint of bacteria on it, from the ones that kind of founded there and got dominance. And even when you clean your teeth, it just grows back to that kind of scuzzy stuff.
What stops them mixing from one tooth to another?
Because they're quite deep underneath the kind of layers of liquid and the bacteria, they don't move between. But also it's so well established, like what's in there already is forcing out anyone else. There's no kind of foothold in for other things.
I now don't know whether to feel good or bad about brushing my teeth if I'm destroying these wonderful little ecosystems that are like the bottom of the Antarctic floor.
You should probably brush your teeth.
I should probably brush my teeth, yeah. If you were a virus, John, how would you spread?
If I was a virus and wanted to spread, you'd want to move from the nose to the nose, because that's where you sneezing would expel you furthest away, and you want to be able to go into that kind of that site so you can go to as many noses as quickly as possible. But you'd also want to be really stable so that you can stay on people's hands after they don't wash it when they go to the toilet, and then they can put it on the surface in the tube and the next person can come along and smear it into their own noses.
So basically a common cold. You'd be a common cold.
Common colds are pretty effective at moving around.
We're with Nessa Carey, Hugh Griffiths, John Tregunning, Sarafina Nance and me, Sally LePage. A quick pit stop though, it's time for the 4th and final clue of our Guess Who. Let's get you back up to speed. We have this sound. Right, we already know this isn't a noise you can normally hear with your ears. I used to only exist in the tropics, but now I can be found all over the world. And your new clue is, I live on dead wood and I'm currently being studied for drugs to treat cancer. Hugh, any ideas?
It's not a fungus of some type, is it?
Is it a fungus? We will find out at the end of the show. Ooh, suspense. Nessa, We have just been hearing from John about eradicating diseases with vaccines and other methods, and even hearing about cystic fibrosis affecting people's lungs. Vaccines only work for infectious diseases, not for genetic diseases like cystic fibrosis. So, from a genetics point of view, do you think we'll be able to eradicate genetic diseases as well in the future?
In theory, yes, some of them. In reality, probably no, just because it would be very difficult to do. But we have this amazing technique now called CRISPR, which is basically a way of changing DNA. Every human inherits 3,000 million letters of DNA information from their mum and 3,000 million from their dad. So you get 3 billion of each. And sometimes just one of those might be wrong. 1 out of 3 billion, it can give you a really devastating genetic disease. Sometimes it's a bit more than that. So in cystic fibrosis that John mentioned, it's 3 letters typically cause the most common form of cystic fibrosis. And it used to be you could do nothing about it. But now this technique of CRISPR is this amazing way of changing DNA information incredibly precisely and incredibly sensitively and very, very effectively. And we're starting to use that to treat diseases.
How could we do that, though? Because I've got millions or billions of cells in me, and you'd have to change the DNA in every single cell, right?
Well, there's 2 ways of doing it. So you have far more cells than that. You have 70 trillion.
Oh, I feel very good about myself now.
Yeah, if you counted them at 1 cell a second, it would take you 1.5 million years. It's an incredible number of cells. If you look at the disease that we're closest to treating right now, using this technique, it's sickle cell disease, which is a disease of the red blood cells. And to treat that, you don't have to treat every cell in the body because most of the cells in the body are absolutely fine with sickle cell disease. It's only the ones that are in the red blood cells. So what companies are doing, because this is all being done by drug companies, is they take bone marrow out of somebody with sickle cell disease.
Because bone marrow is what produces the red blood cells.
That produces the red blood cells. And then they use this technique, CRISPR, to correct the genetic defect in the bone marrow. Then you inject that bone marrow back into the original patient, and it starts producing normal red blood cells. So you can actually cure sickle cell disease rather than treating it, which is just astonishing.
Does that mean that there are people walking around that we have genetically altered already?
Yes, there are. And the initial results are amazing. You have people who used to have to go to hospital for transfusions every month, who were in massive pain every month, who now haven't been in hospital for over a year. Now, the thing is, though, there you're treating and probably curing the individual. But if they have kids, they still have a 50% chance of passing on that defective gene to their children. We do, in theory, have the option of actually wiping out a genetic disease in a particular family, which would be basically when an egg and a sperm fuse and they form the zygote, which is that single cell from which all these 70 trillion others are eventually derived. You can use this technique, in theory, in that zygote. And you'd have to do this in the test tube environment, so it's test tube baby technology. And then if you correct the genetic mutation and you implant that zygote back into the mother, every cell that comes from that original zygote, all 70 trillion of them, they will all have been corrected, and you will have stopped that mutation and that disease in that family. Now, that's going to be amazingly expensive, and there's lots of ethical issues. You're not allowed to do it at the moment.
But we have the technology to do it.
We have the technology to do it, and we know that this works in other animal species. We will see a big change.
Hugh, we've got a nice little question for you here from listener Rakesh. Can you swim in the Antarctic Ocean?
The answer is I can't, because actually we have rules against it at our stations after we actually had an accident where somebody was killed by a leopard seal, which is the not very fun answer.
Oh my goodness. I was just about to ask, because a lot of your research is done on boats. So at some point, somebody must have fallen overboard once. And it wasn't the cold that was the issue, it was the leopard seals.
So this was someone who was snorkeling at the time. So we have scuba divers, but they also used to do some snorkeling. And we now have to have lots of hours of seal watching before people enter the water and be really careful about how we do those kind of things. But there still are in some research stations midwinter swims where they will actually go into the sea in Antarctica and have a little swim around. And it is incredibly cold. And it's quite amazing that human bodies can cope with swimming for a fairly long period of time in that temperature of water, as long as they're sorted out properly when they get out. And if you've prepared for it and So it's like the people who get out of a sauna and get into some Finnish lake or whatever, and it's very cold when it's iced over. You can do that, but you just have to get somewhere nice and warm yourself up properly afterwards. So I've paddled in Antarctica, and I can tell you that it felt like pins and needles. It was the most horrible cold that I've ever felt. So beyond that, I don't know anyone would go any further than their ankles, to be honest. But if they want to do it, it is doable.
And midwinter, it's pitch black as well. So not only is it freezing, you can't see anything.
Yeah.
Not for me.
No.
Sarafina, coming back to you, we've got this space question in from listener Ben. If the moon was formed from a collision into Earth, why is the moon white and the Earth isn't?
That's a good question. There are several different aspects to this answer. One is that the moon doesn't have life on it. The Earth has oceans, it has different land masses. The other thing is the moon is composed of various elements like oxygen and silicon that contribute to the gray color of the moon that we see. And then you have sort of this volcanic activity where a lot of the rocks that are on the surface have actually been expelled from the inside of the moon and then during volcanic eruptions and then end up on the surface of the moon. But ultimately, I think the big thing is that when we look at the moon from the Earth, we are seeing it as particles in the atmosphere scatter certain types of wavelengths of light. And so blue is scattered very easily and red isn't. And so depending on where the moon is in the atmosphere, if it's closer to the horizon versus higher up in the atmosphere, the moon actually changes color.
What's in the middle of the moon?
Cheese, John, don't you know?
I think Sally has the best answer. There's some volcanic activity on the moon, but it has a lot of impact craters from various planetary bodies and other sorts of bodies that have rammed into it. But I actually don't know what the substructure is as you sort of penetrate the surface of the moon.
But you can find out. I bet you are desperate to land on the moon, Sarafina.
Yeah, I'll go there and I will let you know.
John, back to you now. As an infectious disease researcher, it must feel like suddenly everyone in the world is really interested in your research. And so we've had a lot of very similar questions from our audience, such as this one from Amanda. What do we need to do in the future to stop another pandemic from happening?
So we can't. There will be other pandemics. The biggest threat at the moment is actually bacteria that we can't treat with antibiotics. And that's a kind of slow burn pandemic. It's similar to the kind of global heating problem that we're seeing. We can develop better tools to deal with them quicker. So we can make vaccines faster. We can understand how to contain them. The reason why SARS spread so quickly is because people were spreading it when they were asymptomatic. So you could basically be infected, pass it to somebody else, and it just this kind of invisible mass of viruses. So the short and not very optimistic answer is that no, there will be more pandemics. We just have to build the toolkit to deal with them once they happen.
Well, Nessa, Christina's got in touch to ask us about one of your specialist topics, epigenetics. She asks, do modern-day lifestyles affect our epigenetics? If so, can we expect this lifestyle to affect the evolutionary trajectory for humans? So first off, what is epigenetics?
Right, so everyone knows about the genetic code, which is DNA and which is very stable and doesn't change much during your life. But on top of that, there's additional information called epigenetics. It's a bit like if you think about a book and then you put post-it notes in the book to highlight certain things.
Or the worst, the people who draw on books with pens.
Oh yeah, but there is a special circle of hell for those people. So, we're going to leave those to one side. So basically you have this additional information written all over your genes, which controls how genes are expressed. Modern lifestyle, yes, will be affecting epigenetics. So it will be changing that epigenetic system. Doesn't mean that's a bad thing. It's the epigenetic system is part of how we adapt to the environment around us. Hugh's little toes will have been epigenetically altered by paddling in the Antarctic. I don't even know paddling in Norfolk. I don't know what the heck he was thinking. But anyway, everything that we do will be influenced in exactly the same way that people in the Middle Ages were epigenetically influenced by living with their pigs in their hovels, etc. It's just a way of adapting. And people worry that we pass this epigenetic information on to next generations, and under very rare circumstances, maybe we do, other species do, but we don't need to worry about it. In the great scheme of things, the thing that is important is what you're experiencing at the time. So no need for epigenetic panic. There's a lot more things that I would panic about before I worried about epigenetics.
And on that unreserved optimism, we are very nearly out of time for today. But before we go, I have to put you out of your misery and tell you what the mystery sound is. But before I reveal the answer, I have got one more clue for you. This is the sound. We know that this isn't a noise you can normally hear with your ears. I used to only exist in the tropics, but now I can be found all over the world. I live on dead wood, and I'm currently being studied for drugs to treat cancer. And the final clue, this is a fun guy to have in your kitchen. Hugh, you are looking very proud. So what do you think the answer is?
I think it's a fungus of some sort.
It is indeed a fungus of some sort. The answer is a shiitake mushroom.
How's it making the noise?
Well, funny you should ask that, Nessa. These sounds were produced by living fungi, shiitake mushrooms still attached to their mycelial bodies, as part of an art installation by Michael Prime. All living organisms produce a faint electrical current as they move ions in and out of their cells. And what Michael did is he used tiny electrical sensors so that this current controlled an oscillator to produce the sound you heard. That is the sound of the shiitake mushroom growing.
You see, this is so frustrating because that was absolutely going to be my next guess.
It was right at the tip of your tongue,
wasn't
it?
That whole oscillator fungusy what's it thing that you just said, that was absolutely my next guess. Hugh just got lucky there.
My first thought was crocodiles, so don't worry about that. If they come to me first, it would have been crocodile.
But there we must leave it. Thank you very much for listening and for sending in your questions. And thank you to our panel, Nessa Carey, John Tregonning, Sarafina Nance and Hugh Griffiths. Next week, we're learning all about wonderful wood and asking if this ancient building material can help us solve 21st century challenges. The Naked Scientists comes to you from the Institute for Continuing Education at the University of Cambridge and is supported by Rolls-Royce. I'm Sally LePage. Until next time, goodbye.